What about ties? So let's pretend you have a little data set that looks like this. Maybe there's a 5 and a 7 and an 8, but maybe 9 occurs 3 times, and maybe there are 2 11s and then a 50. Okay, so maybe this is your data. Well, let's try to rank them. Let's try to turn these into ranks. So let's see. Well, this is the lowest value and the second lowest and the third lowest. Okay, so far. What about these next values? Well, I could call them 4, 5, 6, but that doesn't seem right because they're all the same as each other. What is the average of these numbers, 4, 5, and 6? Well, it's 5. So the strategy is we put a 5 for all of these, right? So when we have a tie, one strategy that's common is to take the average of the ranks for the tied values. So if this is supposed to be the average of 4, 5, and 6, now that we get to here, we should have 7 and 8. But again, those are tied values. And so we're going to erase the 7 and the 8, and we're going to write a 7.5, which is the average of 7 and 8 for each of them. That's the equivalent of 7 and 8, and then this will be 9 because that's the highest rank. So that is one common way to deal with ties. This is appropriate if you have only a couple ties or a few ties. This would not be appropriate if your data set was full of ties. If your data set is full of ties, you should not be doing a rank sum test. But this is the way to deal with it if you're doing it by hand, or the way that most software packages will deal with this by default. One quick thing to note is that if you are using R to run a rank sum test and you use the function wilcox.test, if there's even one tie, R will return a warning. That's okay, right? The warning just says, hey, you have a tie. That's not a problem. R wants to always let you know that it dealt with ties in this way if there was at least one of them, but you don't have to stop what you're doing. It's just letting you know.